Hi, welcome back to the course. In previous session, we have learned in detail about deep learning, how deep learning started, how it's evolved, and what are the challenges it faced while evolving, and how it's shaping the future today. And we know that today any kind of classification is possible because of deep learning inventions. So that was our previous sessions. Today we are going to see in detail about computer vision. Computer vision is nothing but how humans sees how we can able to replicate this same. For example, if I see the surrounding, I can able to locate where camera is located, where my light is located, where is mobile phone is located, where my laptop is located. I can locate them in precisely because this kind of location needed in many kind of application. For example, if we take some critical security area, for example, if I take bank, if somebody goes nearby locker at unknown time, we should trigger the alert. In this situation, we have to exactly locate the human being and track them so that we can able to alert them in a right time. If we didn't locate them, if somebody is not there at the critical area, if they're somewhere around the not inside the critical area also, alert will be triggered. So to locate them precisely, we need object identification and localization. To solve this problem, we have to identify object and locate them. Not only in kind of critical security things, and also when it comes to autonomous cars, we have to exactly locate where car is coming, how trees are located, how road is mapped. Without precise locating these objects, no, autonomous car not at all possible. So this kind of real world applications, so locating the object, identifying them and segmenting them is very important. To solve this problem, computer vision is the key. So in this video, we are going to see in detail about computer vision, how it started, how it's evolved, and what are the challenges it faced while evolving, and how it's shaping the future today. Let's get started. In the roadmap of computer vision, we can see that in 1960s to 1980s, there is no CNN, any kind of advanced deep learning architecture. That time, people wants to locate the objects, detect the objects. To initiate them, the researchers came up with some kind of mathematical filters. For example, Gaussian blur filter, canny edge detector. So researcher aimed to detect the edges in the images and then reduce the noise in the images. There's some kind of basic kind of image processing. Everything was invented in between 1960 to 1980s. As I told, canny edge detector can able to detect the edges in the images. For example, X-ray, right? It can able to detect the edges of bones and everything. For example, the canny edge detector also used for identifying our fingerprint and locating them. Like that, removing the noise of the image and basic image processing technique, everything was successful in 1960 to 1980s. But what is the challenge here? See, we can able to now detect the edges and shapes, and we can able to apply some kind of image processing techniques, but we cannot able to identify the human beings, objects, face detection. Everything was not possible. So this is a key challenge in 1960 to 1980s. And then the second stage of roadmap is about 1980s to 2000. In this area, the researchers want to detect the objects like human being, face, and kind of objects, car kind of objects, without help of any CNN or advanced architectures. As we know that in 2012 only, AlexNet, there is a very good deep learning architecture came into the place that enables all kind of object detection with help of deep learning architecture. But in 1980s to 2000, researchers, they aim to identify objects like human being and face, and they achieved also without help of any deep learning techniques. That's what we are going to see now. How this happened? There are two major techniques researchers invented. One is the hair cascade method. Second one is the HOG, histogram of gradients. We'll see about how hair cascades and HOG used for detecting faces and human being. When we see hair cascade method, it helps to detect the faces. How it happens? For example, it identifies the faces with help of dark and light color changes in the image. For example, when we see our face, we can know that eye is darker than forehead, and nose is little darker than other place, and lips is darker than skins. Like that, there will be darkness differences there in our faces, right? Like that, researcher took template of an image for multiple persons. They took the complete pattern, how each part of the darkness and light color changes over the face. Like that, researcher took complete 10,000, 20,000 faces of patterns, and then they are stored in a separate file, and this file and this pattern is used to identify the human face without help of any deep learning architecture. So this is what the R cascade method. And second part is about HOG, histogram of gradients. This helps us to detect the objects like human being. How it does? Like instead, like air cascades works based on brightness level, dark and light color. Instead, like HOG method, they used like what are the like histograms. For example, if I take my leg, there are a lot of edges will be there, no vertical edges will be there in my leg. So if you take my shoulder, lot of horizontal edges will be there. So that for each human being part, like what is the combination of like edges, how many edges, like for example is horizontal, how many edges are vertical, how many horizontal, how many are like up and down, like that the calculation counting based on the edges was clubbed together, and this kind of pattern is stored for multiple persons, and then this method is used to identify the objects like human being. For same method can be used also car and other objects also, but the HOG method is very successful for identifying the humans without help of any deep learning architecture. So this is how like HOG works. It divides the entire image into the complete grid, for example different grids of image, and then it will identify the edges pattern based on the like edges gradients. No, it tries to calculate the histogram, what's the number of counts of each edge, what's up and down, left and right, as I told before. Based on this combination of pattern, it will store it in a separate file for multiple persons, and then when given image, no, it will can able to identify the pattern again. I can able to match whether the person is human or not, and it can able to locate it. So this is what the invention happened at the HOG to identify the human being. Now you understood how HOG and air cascades method used to identify the humans and the faces. Now we understood how HOG and air cascades method used to identify the faces and the human being. So like in this invention, like it's very good for identification, but when it is deploying to real world applications, no, it is not suitable because it's a very slow, it cannot be used in the real time. To solve this problem, after invention of AlexNet in 2012, there's a technique called RCNN, region based CNN is invented. So what does RCNN mean? For example, like they have taken image and then they have divided into 2000 parts. Like 1, 2, 3, 4, like the 2000 parts, they divide the image. For each region, no, 2000 separate regions, no, they applied the CNN model into separate region 2000 times. So per image 2000 times CNN model is applied to the each region. So this is a selective search and a pixel to pixel kind of, you know, like a search will happen. This is very slow, even though we can able to locate them, but it takes nearly 40 to 50 seconds to analyze the single image to identify the objects. Even though it's a very good start, but it's not at all suitable for the real world problem. So RCN is the like beginner for the object detection like solution. And then after RCNN, the challenge was, we know that it cannot be used for real time. In 2015, faster CNN is invented. We know that like RCNNs cannot be used for real time. In faster RCNN, no, they have introduced RPN network, region based proposal network. In 2015, faster RCN is invented. Comparing to RCNN, in faster RCNN, RPN technique is used. Region proposal network is invented, and then it is integrated along with the like RCNN. For example, we know that like RCNN divides the image into the predefined 2000 parts, but instead the faster RCNN, no, it will not be predefinedly divide the images. It will take the images and then it try to locate the object with the bounding box. That's the technique RPN was helped to achieve it. So in this scenario, no, like we are not predefinedly dividing the images into 2000 parts, whereas we are taking the image and then we are applying some kind of CNN algorithm, and then with the help of RPN network we are able to locate them in the bounding box within the image. So while training, no, the location accuracy keeps on increasing, and then it helped us to like achieve the location precisely. But here also, no, like per image, like locating the object, it takes 0.2 seconds to 0.5 seconds. Comparing to like, you know, like see RCNN, like faster CNN is very much fast, but still it's not deployable in real world problem, because in real world at least we need 30 frames per second to 60 frames per second to work in the autonomous cars, but it's only around is 5 fps. So it's a better improvement, but this is not used for real time even though, but it can be used in real time as same like RCNN, but it's a better improvement, right? So this is the faster RCN invention. After that, To solve the problem faced in faster RCN, researchers came to invention of YOLO model. So YOLO is nothing but you only look at the once model. So instead, it also divides the image into multiple parts, same like RCNN, but instead it will not do the inference for each part of the image. To solve the faster RCNN problem in 2016, YOLO model came into the place. For example, YOLO is nothing but you only look at once. Instead, in RCNN, we divide the images into 2000 parts and then we do the inference separately for each region. But in YOLO, it also divide the images into 7x7 grid into multiple segments. It will divide it, but it will not apply the CNN to each part. Instead, it will apply the CNN in a single pass to the complete image at once. Because of this kind of invention in YOLO, we can able to achieve the good accuracy as well as the high level of FPS, frame per second. We can able to achieve 30 frames to 60 frames easily with the help of YOLO architecture. So this YOLO enabled us to use the this kind of object detection kind of method in real world problem in autonomous cars and many places. So thanks for the YOLO team for enabling us to use the computer vision in real world applications. See, as of now, what we saw is that object location. Whenever we see an image, we'll be locating the object. Where is the table? Where is the mobile phone? There's a rectangle box used to locate the object. This is the one vertical of the computer vision, locating the object. The second vertical is that segment the object. For example, where segmentation required. For example, if I take some brain tumor kind of MRI scan, I cannot only tell tumor is present or not. Instead, I have to locate it and segment it exactly. To solve this segmentation problem, in 2017, Mark RCN is invented by the researcher. So Mark RCN, what it does know, it's same like fast RCNN. It can able to identify and locate the object as a rectangle box. After the rectangle localization, it involves some binary masking region. So it can able to exactly segment it. For example, if I'm a person, fast RCN will give the rectangle box around me. If the mask RCN after rectangle box, it try to segment me exact shapes. So this is segmentation, it used in the many applications. So this segmentation after Mark RCN, before that also many segmentation algorithms try to solve the medical problem also. UNIT came into the place. That architecture help us to precisely segment the brain tumors and any medical diseases. So UNIT was very helpful in segmenting the medical kind of images, and then mask RCN is very helpful in segmenting the real world objects, human beings and everyone. Now understood what is segmentation mean. There is three types of segmentation we have to understand. One is the semantic segmentation, and instant segmentation, and panoptic segmentation. For example, semantic segmentation is nothing but it can able to identify what's the background, what's the road, and it will treat all the objects into the unique objects. If there's a multiple different model of cars there in the road, it will treat all the cars into the same model. It will assign the unique ID. So this is the a semantic segmentation. But in some use cases like autonomous car, we have to label each kind of object with unique label. To solve this, identifying each object separately, instant segmentation was invented. Instant segmentation, it will not identify background or anything, but it can able to precisely locate each object separately with separate mark with a unique label. So this was achieved with the help of the instant segmentation. Now the panoptic segmentation is combination of both. The combining the semantic segmentation and instant segmentation, researchers came up with a concept called panoptic segmentation. Now with the help of panoptic segmentation, we can able to identify the background, road, and also we can identify the different objects, and then we can locate them, identify them, we can label them uniquely with the help of this panoptic segmentation. So this panoptic segmentation technology is majorly used in the autonomous cars to make the car to take the better decision, and then today we know autonomous cars are really working well. So the main invention being the autonomous car, one of the technique called panoptic segmentation. With help of panoptic segmentation only, the autonomous cars can able to segment each and everything which it will see, and segment everything and plan the path in efficient way. So now you have understood what is the a computer vision and how it started with edge based detection, and how it came able to identify the faces and humans without help of deep learning architecture, and after deep deep learning architecture came into the place, how like RCNN, fast RCNN came into place and solved the object detection problem, and then like how like Euler came into place that solved the real world deployment problem, and then how mask RCNN and unit everything came to solve the segmentation problem. This and all the like complete roadmap of computer vision. And today when it comes to 2020 to 2025, and we can see that lot of new architecture came into the place. Like previously all the like object detection and segmentation method was used CNN as the backbone for identifying the object, but now we see that a transformer is came into the place. Vision transformers, like it's a better than CNN for huge data sets. Like CNN can able to classify the objects, but the transformer can able to understand the relationship between the objects. So if there's an object, like for example a person swimming in the sea, the transformer can better understand the relationship between the sea and person and swimming pad. So this is the relationship based transformer. It works very good for bigger level data sets and relationship based scene understandings. So now vision transformers are used for classifying the objects as well as the like locating the objects and segmenting the objects. Now this vision transformer are used everywhere mostly because it works for very bigger level data sets and the smaller level objects. As we said in YOLO, that works very well for real-time application, but for smaller object accuracy was poor. So to solve this problem also, the vision transformers works very well for bigger kind of data sets, and also smaller objects also it works well. So nowadays vision transformers, and then like for segmentation, the Facebook Meta, they came up with a very good model called segment anything model. Using that segment anything model without training anything from scratch, we can able to segment any part easily. So like that vision transformers kind of segment anything model, this kind of large language models, like bigger vision language models we call as in computer vision. So this is changing the world today. So like in future we'll be learning in the transformers, and then how transformers came, how like transform is better than CNN, and what is the core concept, like what is self-attention method, and everything we'll be discussing in detail in the next session of the video. Thank you so much.